Dear students, welcome back. In the previous lecture, we started the topic lines and angles. So today we'll continue with that topic only. In the previous lecture, I told you about acute angle, obtuse angle, reflex angle, right angle, and I told you about the linear pair, adjacent angles and all. So we did few examples also. Today we'll start with few examples and then I'll tell you few more angles. Okay, about few more angles. First of all, the first example. PQ is a straight line and OR is perpendicular to PQ, and then there is a line OS passing through O. Then you have to prove that angle ROS is equal to half of angle QOS minus angle POS. You have to prove that angle ROS is equal to half of angle QOS minus angle POS. Now we'll start with let angle ROS is equal to x degree. We have assumed that this angle is x degree. Now you can see that angle QOS will be equal to 90 plus x. Okay, because this is 90 and this is x, so angle QOS will be 90 plus x, and angle POS plus x plus 90 is equal to 180 because it's a straight line. See, POS means this angle plus x plus 90 will be 180 because POQ is a straight line. The reason is POQ is a straight line. POQ is a straight line. Now you see angle POS will be equal to 180 minus 90 minus x, that is equal to 90 minus x. So we have found angle POS and angle QOS. Now we'll start with the right hand side of the question, and the right hand side of the question is half of angle QOS minus angle POS, that is half of, now you see QOS, angle QOS is actually 90 plus x, and minus angle POS is 90 minus x, so we'll write 90 minus x here. Now if you open the bracket, then it will be half 90 plus x minus 90 plus x. You see, when you open the bracket, there is a negative sign outside, so this sign will change and it will become minus 90 plus x. Now plus 90 minus 90 cancels out, half into x plus x is 2x. So if you cancel 2, you will have only x, but x is nothing but angle ROS. So this is nothing but angle ROS. So we have proved the left hand side. We started with the right hand side and we have proved the left hand side, that is it is equal to ROS. Clear? Now we will do one more example. Next question is find two supplementary angles in which one is 30 less than 30 degree less than twice the other. That means you have to find two supplementary angles in which one angle is 30 degree less than twice the other angle. Let the angles are x degree and y degree. We have assumed that the angles are x degree and y degree. Now, first of all, as it is given that these two angles are supplementary angles, so their sum must be 180 degree. I told you, when the sum of two angles is 180, then they are called supplementary angles, and when the sum of two angles is 90 degree, then they are called complementary angles. So, as x and y are supplementary, so x plus y is equal to 180 degree. This is equation number 1. Now, the other condition is that one angle is 30 degree less than twice the other, means x is equal to 2y minus 30, you can say. They are saying in which one angle is 30 less than twice the other, means twice y. So this is, if you shift 2y to this side, x minus 2y is equal to minus 30. This is equation number 2. Now we will solve these two equations simultaneously and we will get the value of x and y. So x minus 2y is equal to minus 30, and below it you write x plus y is equal to 180. Now you change the sign, minus minus minus, plus x minus x cancels out, minus 2y minus y will be minus 3y is equal to minus 180, and minus 30 is minus 210. So it is minus 210. So minus n can be cancelled. Y will be equal to 210 upon 3, that is equal to 70 degree. So we have found y is equal to 70 degree. Now we will put y is equal to 70 degree over here. So x plus 70 degree is equal to 180 from equation 1. So x will be equal to 180 minus 70, that is 110 degree. So you can see we have found x is equal to 110 degree and y is equal to 70 degree. X is 110 degree and y is 70 degree. That is our answer. You can see the sum of x and y is 180 because they are supplementary angles, and if you double y, that is 140, and then subtract 30, you will get 110. So that means the second condition is also fulfilled. So your answer, x is equal to 100. One angle is 110 degree and the other angle is 70 degree. Clear? Now we will do one more question. And the question is, there is a straight line R O S is a straight line. Now this is P, this is Q. This angle is given 90 degree. This angle POR is given X, and this angle QOS is given Y, and one more line is there like this, OT. This angle is given 75 degree, and this angle is given, SOT is given 3x. Now using this diagram, you have to find the value of x and y. So first of all, you see, as ROS is a straight line, I told you there was an axiom that if OT stands on a straight line, then the sum of these two angles, the sum of the adjacent angles will be 180, or they are forming a linear pair. Therefore, their sum will be 180. So you see 3x plus 75 is equal to 180. The reason? Linear pair. They are forming a linear pair. So 3x plus 75 is equal to 180 degrees. Now 3x is equal to 180 minus 75. So 3x is equal to 105. So x is equal to 105 by 3, that is 35 degree. So we have found that x is equal to 35 degree. Now still, as you can see, ROS is a straight line, so the sum of x, 90, and y will again be 180 because it is a straight line. So x plus 90 degree plus y is equal to 180. Now the reason you will write, ROS is a straight line. ROS is a straight line. So as ROS is a straight line, so the sum of these three angles will be 180 degree. Now x we have already calculated, so you put the value of x over here. 35 plus 90 plus y is equal to 180 degree. Now 90 plus 35 will be 125 plus y is equal to 180 degree. Now y will be equal to 180 minus 125, and when you subtract 125 from 180, you will get 55 degree. So you can see x is 35 and y is 55 degree. We have found x is equal to 35 degree and y is equal to 55 degree. And that is your answer. X is equal to 35 degree and y is equal to 55 degree. Clear? Now with this we have done few more examples, and now I am going to tell you about few more angles. Now see, PQ and RS are two lines which are parallel to each other. PQ and RS are two lines which are parallel to each other, and there is a line MN. There is a line MN which is called a transversal, which cuts PQ and RS. It cuts PQ at say point X and RS at point Y. Okay. Now I name this angle, means angle MXQ, as 1, then MXP as 2, then QXY as angle 3, and PXY as angle 4, this angle as 5, this as 6, this as 7, and this angle as 8. So I have named these angles in this way. Now first of all, on the basis of the previous lecture or on the basis of your previous knowledge about the angles, you can easily say that angle 1 is equal to angle 4. Now why angle 1 is equal to angle 4? Correct? Because they are vertically opposite. In the previous class I explained what are vertically opposite angles, and I told you that vertically opposite angles are always equal. So 1 and 4, they are vertically opposite, so they are equal. Similarly, angle 2 and angle 3, they are also vertically opposite, so they are equal. Angle 5 is equal to angle 7 because they are vertically opposite, and angle 6 is equal to angle 8 because they are also vertically opposite. Angle 6 is equal to angle 8 because they are also vertically opposite. So the reason for all these angles will be vertically opposite. Okay, these angles are equal because they are vertically opposite. Now angle 1 plus angle 2 is equal to 180. Why angle 1 plus angle 2 is equal to 180? Correct, because they are forming a linear pair. Similarly, angle 1 plus angle 3, again 180, and the same reason. Angle 2 plus angle 4 is equal to 180, again the same reason, because they are forming a linear pair. Angle 3 plus angle 4 is equal to 180 because they are also forming a linear pair. Angle 5 plus angle 6 is 180. Angle 6 plus angle 7 is equal to 180 degree. Angle 7 plus angle 8 is equal to 180 degree. And angle 5 plus angle 8 is equal to 180 degree. And the reason for all of them is the same, that is, they are forming a linear pair. Linear pair. I hope vertically opposite angles and linear pair is clear to you. Now I'll tell you about few other angles. Although you have already studied about them in the junior classes, angle 1 and angle 5. Angle 1 and angle 5. They are called corresponding angles. Corresponding angles. When two parallel lines are there and there is a transversal, then this angle 1 and angle 5, they are called corresponding angles. Similarly, angle 2 and angle 6, they are also corresponding. Angle 2 and angle 6, angle 2 and angle 6. Similarly, angle 3 and angle 8, angle 3 and angle 8, they are also corresponding. And angle 4 and angle 7, they are also corresponding. Angle 4 and angle 7, they are also corresponding. So we have 4 pair of angles and they are called corresponding angles. So we may represent them like this. These are all corresponding angles. These pairs are called corresponding angles. Now angle 4 and angle 5. Angle 4 and angle 5. Angle 4 and angle 5, they are called alternate interior angles. Similarly, angle 3 and angle 6. I repeat, angle 4 and angle 5 and angle 3 and angle 6, They are called alternate interior angles. Okay, you can see when there is formation of Z like this, then these two angles are called alternate interior angles or simply alternate angles. Similarly here also it is a reverse Z, so 3 and 6 they are alternate interior angles. And now angle 1 and angle 7. Angle 1 and angle 7. Angle 1 and angle 7 and angle 2 and angle 8. They are called alternate exterior angles. Alternate exterior angles. Okay. I repeat, angle 1 and angle 7 are the alternate exterior angles. Angle 2 and angle 8 are for the they are also alternate exterior angles. Clear? Now you see angle 3 and angle 5. Angle 3 and angle 5 and angle 4 and angle 6. Angle 3 and angle 5 and angle 4 and angle 6. They are called co-interior angles. Okay. Angle 3 and angle 5 and angle 4 and angle 6, they are called co-interior angles. There are few more names of these angles. They are also known as allied angles, or they are also known as consecutive interior angles. They are known as co-interior angles or allied angles or consecutive interior angles. Okay. Now I'll tell you few axioms and theorems regarding the properties of these angles. But before that, I can tell you that corresponding angles are equal. When the two lines are parallel, PQ and RS, then the corresponding angles are equal. Means angle 1 will be equal to angle 5, angle 2 will be equal to angle 6, angle 3 will be equal to angle 8 and angle 4 will be equal to angle 7. Corresponding angles are equal. Clear? The corresponding angles are always equal. Now, what about the alternate interior angles? Alternate interior angles are also equal. Alternate interior angles are equal. Then what about the alternate exterior angle? Alternate exterior angles are also equal. Okay. So the corresponding angles, when the two lines are parallel and one transversal is there, the corresponding angles are equal. Alternate interior angles are equal. Alternate exterior angles are also equal. But the co-interior angles or the allied angles, they are supplementary. Means their sum will be 180 degree. So co-interior angles or allied angles, they are supplementary. Okay, so always remember co-interior angles or allied angles or consecutive interior angles, their sum will be 180 and that is why they are supplementary angles. Angle 3 plus angle 5 will be equal to 180 and angle 4 plus angle 6 will be equal to 180. Clear? So these are some new angles and now there are few axioms and theorems based on these these angles. Axiom 1, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. Each pair of corresponding angles is equal. So that I have already told you that corresponding angles are equal, but this is the axiom: when a transversal intersects two parallel lines, then the corresponding angles are equal. Now, as this is an axiom, I told you axioms are not proved. Okay, these statements, they are taken as true, they are assumed to be true without any proving. Clear? Now the next axiom: if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel. Now if you see, this axiom 2 is actually the converse of axiom 1. In axiom 1 it is said that when a transversal cuts two parallel lines, then corresponding angles are equal. In axiom 2 they are saying if a transversal cuts two lines and the corresponding angles are equal, then the lines are parallel. So it is simply the converse of axiom 1. Now I'll tell you few theorems. So theorem 1, if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the lines are parallel. So that also I have already told you that if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the lines are parallel. But as it is a theorem, so we have to prove it. So there are two lines, one is AB and the other is CD, and there is a transversal, say PQ. This point is M, this point is N. Now you know that this angle and this angle, they are called the alternate interior angles. These angles are called alternate interior angles. Now they have given that the alternate interior angles are equal, means if this angle is x, then this angle is also x. It is given. Now if this angle is x, what about this angle? You are correct, it will be x because they are vertically opposite. The vertically opposite angles are equal, so that angle will also be x. Now you see these two angles, they are called corresponding angles, and when the corresponding angles are equal, the lines will be parallel. That is your axiom 2. Clear? So I repeat, in the theorem they have given that these two angles are equal, alternate interior angles are equal. If this angle is x, then that angle will also be x because they are vertically opposite. And now this angle and this angle, they are equal, they are corresponding angles, and when corresponding angles are equal, this proves that AB is parallel to CD. Clear? Now theorem 2, if a transversal intersects two parallel lines, then co-interior angles are that again I have already told you that if a transversal intersects two parallel lines, then the co-interior angles are supplementary. But as I told you, this is also a theorem, so you have to prove it. Now see, there are two parallel lines, say AB and CD. Now it is already given that they are parallel. There is a transversal PQ. This point is M, this point is N. Okay. Now you know that these two angles are actually co-interior angles. So we assume that this angle is x and this angle is y. Okay. We assumed that this angle is x and this angle is y. Now first of all, if that angle is x, then this angle will also be x because they are alternate interior angles, and in theorem 1 we have already proved that when the lines are parallel, the alternate interior angles are equal. So if that angle is x, this angle will also be x because they are alternate interior angles, and x plus y will be 180 degree because they are forming a linear pair. So x plus y is equal to 180 degree because they are forming a linear pair. But the end result is that this angle x and this angle y, their sum is 180, means co-interior angles are supplementary. So we have proved that co-interior angles are supplementary. The co-interior angles are supplementary. Okay. Now, next theorem. Next theorem. If a transversal intersects two lines such that a pair of co-interior angles are supplementary, then the lines are parallel. So you can see this theorem 3, it is the converse of theorem 2. In theorem 2 they were saying that when a transversal intersects two parallel lines, then the co-interior angles are supplementary. Now they are saying if a transversal is intersecting two lines and the co-interior angles are supplementary, then the lines are parallel. So it is simply the converse of theorem 2. Now see, AB and CD are two lines, although they look like they are parallel, but it's not given that they are parallel. Now PQ is a transversal, this point is M and this point is N. Now they are saying that the co-interior angles are supplementary, means if this angle is X, then this angle will be 180 minus X, because you know their sum, it is given that they are supplementary, so their sum will be 180. So if one angle is X, then the other angle will be 180 minus X. Now if this angle is 180 minus X, then this angle becomes X because they are forming a linear pair. Clear? These two angles, they are forming a linear pair, so their sum will be 180. So when one angle is 180 minus X, the other angle will be X. And now you see the alternate interior angles are equal, which proves by the axiom that line AB is parallel to line CD. Using the axiom, we can say when the alternate interior angles are equal, so AB is parallel to CD. Clear? Now, theorem 4, lines which are parallel to the same line are parallel to each other, are parallel to each other. Again, it's a very simple thing. Suppose there are three lines AB, PQ and MN. Now it is given that AB and PQ are parallel, and then it is given that AB and MN are also parallel. So automatically PQ and MN will be parallel to each other. If you draw a transversal like this, as AB and PQ are parallel, means if this angle is x, then this angle will also be x because they are alternate interior angles. Now as AB and MN are parallel, if that angle is x, then this angle will also be x. Again, they are forming the alternate interior angles. Now you see these two angles, they are corresponding angles, and when the corresponding angles are equal, this proves that PQ is parallel to MN. Okay, given AB is parallel to PQ and AB is parallel to MN, then PQ is parallel to MN. Okay, so these are few theorems, and now we will do few examples based on these theorems, these properties. The first example, PQ and RS are two lines and it is given that they are parallel. Now this point is x, this point is y, and this point is n. Okay. Now it is given that this angle is 135 degree and this angle is 40 degree. Okay, it is given that this angle is 135 degree and this angle is 40 degrees. Now find angle XMY. You have to find the angle X and Y. So in this particular question, first of all, draw a line passing through M and parallel to PQ. Draw a line passing through M and parallel to PQ like this. Okay. Now see, if that angle is 135, then this angle will be 180 minus, let this angle be x and let this angle be y. So first of all, x plus 135 is equal to 180. Why? Because they are co-interior angles, and I told you when line PQ and this line are parallel, so the sum of co-interior angles will be 180, they are supplementary. So x will be equal to 180 minus 135, that is equal to 45 degree. And now as this line passing through M and the line R is they are also parallel, so y and 40 will be equal because they are alternate interior angles. Clear? So y is equal to 40. So we will mention the reason also. X plus 135 is equal to 180 because they are co-interior angles. And here y is equal to 40 because they are alternate interior angles. Okay, and now we have found x and y, and angle XMY is actually x plus y. That is 45 plus 40. So when you add, it is 85 degree. Clear? And that is your answer. Clear? So in the next class, we'll do few more examples, and then we'll continue with few more topics. So do all the sums given in your assignments and your textbooks. Okay.